Hello and welcome to Algebra 2, Chapter 5.8, Modeling with Quadratic Functions. And so in this section, what we're going to do is we're going to be writing the equations for a parabola given the graph. So we're going to look at 4 different examples. And so here's the first one. In this example, we are given a vertex and one other point. And so when we're given a vertex, we might tend to look at vertex form. So if you remember vertex form, y equals a times the quantity x minus h squared plus k. And to complete this form, you need an a, an h, and a k. While your vertex gives you an h and a k, so there's h and k, but we need an a, and there's no way, nothing's ever going to just give you the a, but if we use another point, say 1, -1 that's given to us, if we use this as an x and a y, we can solve for the a. And so what we need to do then is solve for a. So we're going to substitute in our values. Y is going to be -1, which comes from the point over here. A is a, x is 1, minus h is -2, squared, plus k is 1, because remember that is h, k in our vertex. Okay, so you are solving for a. Let's see here, this is going to be 3 squared plus 1, so that looks like 9a plus 1, minus 1, minus 1, -2 equals 9a. So a looks, that's a 9, a looks to be -2/9. And once you have a, h, and k, all you have to do is write it back in the formula. Y equals -2/9 times x plus 2 squared plus 1. So there is our quadratic function for that parabola. So now we have a different situation. This time, it only specifies one point that it's giving us, but if you look closely, we're given the intercepts. They're just not labeled. And so if it's giving us the intercepts, ideally then you want to use intercept form. So you're looking at y equals a times x minus p times x minus q. And remember, your intercepts are p and q, but again, nothing is going to give you a. And so a is going to be what you're solving for all the time. So if you use this third point as your xy, then what we have left to solve for is a. So this is going to be -6 equals a times 2 minus 1 times 2 minus 4. All right. And so -6 equals a times 1 times -2. So -6 equals -2a. And this means then that a is going to equal 3. And then my form is going to be y equals 3 times x minus 1 times x minus 4. So you're looking for all the other variables besides x and y so that you can replace those. Okay, so the next example, our last example, is going to be if we're just given 3 random points. They're not necessarily the vertex and the intercepts, it's just any 3 points. So if you're looking at a parabola, and maybe we're looking at a trajectory, you're given that one, and that one. And so I want to write an equation that's going to go through all 3 of those. What we're going to do is we're going to plug each point individually into this equation, because each point will give you an x and a y, which means we're going to have a, b, and c. What we're going to make is a system of 3 equations, 3 variables, because we have a, b, and c are our 3 variables, and we're going to solve the system. You can refer back to chapter 4. Let's see here. Actually, you can refer back to chapter 3 when we talked about solving systems using elimination, or you can do Kramer's rule from chapter 4 if you remember that. Once you get a, b, and c, then you're going to write your equation in standard form. So that's going to be our answer here, is going to be in standard form. So here we have a rubber ball's dropped and measured the height in inches if the ball for each of its successive bounces. The results are shown in the table. Find the quadratic model in standard form for the data using the first three bounces. So this would be, if you graphed this, you might look at it bounced this high the first time, this high the second time, this high the third time, and it's going to look like part of a parabola there. So and it specifically says the first three bounces, alright? And so remember I said on that last slide that we're going to use our equation, y equals ax squared plus bx plus c. And so bounce is going to be x, height is going to be y. So our first equation is going to be, and I'm going to switch it around and put the equals at the end. It's going to be a times 1 squared plus b times 1 plus c equals 47. Okay, otherwise known as a plus b plus c equals 47. Our second equation is going to be a times 2 squared plus b times 2 plus c equals 39. Otherwise known as 4a plus 2b plus c equals 39. And our last equation is going to be a times 3 squared plus b times 3 plus c equals 26, or 9a plus 3b plus c equals 26. So here is my system of equations that you're going to solve. So I'm just going to go ahead and use elimination, and I'm going to eliminate c's. That looks to be the easiest. So I'm going to do 1 times a negative 2. I'm going to multiply 2 by negative. So this is a plus b plus c equals 47. Negative 4a minus 2b minus c equals negative 39. And remember, we want to add them together. So this is negative 3a minus b. The c's cancel. Equals 8. And then I'm just going to do 1 times a negative 3. I'm going to multiply 3 by negative 1. So I get a plus b plus c equals 47. Negative 9a minus 3b minus c equals negative 26. Negative 8a minus 2b equals 21. So this is my equation 4 and 5. And I'm going to put those together. And I'm going to go ahead then and take 4 times negative 2 and 5. So 4 times the negative 2 is going to be a positive 6a plus 2b equals negative 16. And then negative 8a minus 2b equals 21. So this is negative 2a equals 5. So a equals negative 5 halves. So there's a. So then I have to find b. So I'm going to just plug b back in. I'll just plug it in right here to equation 5. Let's see here. So negative 8 times negative 5 halves. So that's going to be a 20 that we're going to subtract 20 and get negative 2b equals 1. So then I get b equals negative 1 half. And then I'm going to come back up to a. So we're going to have negative 5 halves plus negative 1 half plus c equals 47. So 47, I'm going to add over 5 halves, and I'm going to add over a half, and so c equals 50. So we had to find a, b, and c, and then you're going to put that all together into a final equation, all your coefficients, and it's going to look like y equals negative 5 halves x squared minus, a minus would be good, minus 1/2 x plus 50. So there's how you find your coefficients to write it in standard form. So let me know if you have any questions. Make sure to take notes. Even if you didn't understand something, then we can go over it in class next time. Hope you have a good day.